In this video, I am going to provide you with my opinion and educated assumptions, let's say, about spray foam insulation. And I think we could be getting carried away with it, and we could be in for some big problems in the future if these problems aren't addressed as soon as possible. And I'm not about to suggest that I'm right on this, but you let me know. Feel free to leave a comment in the comment area. And am I right? Could this be a problem, or have they already solved it and there is absolutely no way that it could be a problem? So the first thing I'd like to do is just kind of go around, show you what some general construction would look like for a two-story home. This would be the second floor, and of course the roof, and just kind of a cutaway here, give you an idea of what it would look like without any sprayed foam insulation. Now here's what it would look like if you could spray the foam on perfectly. Check that out. Nice 90-degree angles, 2 inches all the way around everything. So this isn't going to happen, but it's the only way I could draw it. So let's work with what we have here. So this would be a crawl space or some type of a floor system that would have been sprayed with the insulation. And again, they might not spray the bottoms. Let me go back here. You might end up just spraying this area here, but the reason why I'm making this video is because I came across a video the other day and they had sprayed the entire roof system. They had, it was trusses, and they had sprayed to where it would have looked something like this. The top cords on all of the trusses were sprayed with the foam. And in my opinion, it's going to create a couple of problems either way you look at it. So let's just go ahead and pretend like it's going to create some type of a cavity, something that could trap water. So again, we have something here. We slide our joists in. So let's look at it from two different points of view. Let's say that one of them would be that the foam can somehow allow water to seep or weep past it. And if that's the case, we could actually end up with water if it's a type of foam that does not allow water to penetrate. So if the foam allows water to flow through it, then this would solve the problem of trapping water in here, but could also create another problem from condensation. If you had lived in an area with a lot of humidity, a lot of moisture in the air, then now you've got the problem of moisture getting sucked through the foam or sucked into the foam, and then having moisture on the wood, surrounded by the wood for a long time. This would be kind of act like a sponge if the foam allowed moisture to flow through it or absorb into it. And if it didn't, and moisture couldn't absorb through it, and if that's the case, any water that somehow got into this area, into this cavity, could remain there for a long period of time. And under the right circumstances, accelerate the decomposition process, then that could be a problem, of course. Now, there is something that might be an advantage here for the foam. If the foam wraps all the way around the wood and it's sloping, this might allow water to flow out through the slope. But that's not going to be the case on the floor. Or I should say, it would the water could remain there for a longer period because it is going to be level or somewhat level. And of course, if everything is nice and level, everything is nice and flat, you're still going to have a problem with the plywood gaps. I can only imagine the amount of water that is going to be able to flow through these gaps, especially when the lumber manufacturers require 1/8 of an inch gap between the sheets. Now, on a floor, there's a good chance you're going to use adhesive, glue, on top of the joist. You're going to put it on to prevent the floor from squeaking. So this adhesive could actually create a waterproof barrier here. I don't know if it would. I'm just saying, under the right circumstances, you could end up with a waterproof joint here. And the tongue and groove used for the plywood, if you're going to use square edge plywood with blocks, you're going to actually have a bigger problem because the foam is not going to be in the area that's, if you're using 2x4 blocks for your plywood, it's not going to be, the foam will not be in the area that's going to be 3.5 inches wide now. Now you've got even more of a problem to where you could be susceptible to this situation here. Water actually not traveling past the foam because it's stuck to the bottom of the plywood, but it's going to be absorbing into the edges of the plywood. It's going to be absorbing into the top of the floor joists. If you have enough water over time, does it really matter if it rots out the entire section or just one small section that allows the joist to fall apart? You know, a small section's usually enough, by the way. So for a floor, this could be your problem. The adhesive could help. The tongue and groove could reduce the amount of moisture, but this is not going to be the case on a roof where there is no adhesive and you still have the 1/8 of an inch gap. And all of the water can simply leak through these areas. So you're going to have water accumulating in all of the gaps if there is a leak. And I have seen this before. If you had a gap, let's say this piece of plywood went through and you had a gap here on this roof rafter, I've seen water come down, go around it here, come down and work its way down in between the floor sheathing. This is only going to be a bigger problem if you have created a water resistant or waterproof barrier like this. And if the water is looking for places to go, you might not even be able to find the roof leak. You know, you might look at the edge of your roof rafter and see water leaking out or water leaking over here and think, oh, that's not a big deal. Well, it will be a big deal when the plywood starts to rot and your roof caves in. So I'm going to leave it at that. Hopefully this makes sense. I think I'm going to refer to this video as a public service announcement because it's a question I keep getting over and over again. And that is, can you build stairs in tight spaces with extremely tall risers and shallow treads? And can they be like 24 inches wide? This is actually a question I received just recently. The individual wanted to build a set of stairs that had a 10-inch riser height, 8-inch tread, and it was 24 inches wide. And yes, you can. You can do whatever you want. You can put a ladder there if you want to. The only problem is that your local building department might not like it. You are going to have certain building codes that you need to follow. Now, with that said, and you need to check with your local building department to find those building codes or watch some more of our videos. But this video here, I just want to focus on some of the problems you might run into if you do build a set of stairs like this in a tight space. And number one thing, make sure you have a handrail. This is a must. Make sure that you have a handrail that you can hold on to while walking up and down this type of stairway. And hopefully by the time you have finished watching this video, you will understand why the building departments, why these people have worked this stuff out for your safety and your protection. So again, if you have to build a set of stairs like this, you do not have a choice. I understand. It's just not, you're going to have to be careful using it. You know, you have to understand the local building department isn't going to approve it, or I should say most of the time. And the reason is just because of safety. You fall down one of these sets of stairs once, and you're going to think, why did I build it like that? You know, why didn't I listen to that guy that made that video? So pay attention here. 8-inch deep stair tread, 10-inch tall risers, and your feet are only 10 inches. So these little shoe samples I made are 10 inches. 2 inches of the shoe is going to be sticking off if you butt the shoe up against the riser every single step you make. If you keep the your shoe about an inch away from the riser. Now you are going to only have 7 inches. Now this isn't that big of a problem when you're walking up the set of stairs and holding on to the handrail. But things are going to be a little bit different when you walk down a set of stairs like this. Unless, of course, you walk flat-footed or with your heel first instead of the front of your foot. And most people are going to be walking down a set of stairs with the front of their foot setting on to the front of the step, not like this. You know, you're not going to back your heel up against the riser every single time. And I'm saying this, I'm pointing this out for a reason. Just like I pointed out the handrail. You know, you are going to be, when you're walking up the set of stairs, you're going to want to be propelled forward. If you fall, you're only going to fall a couple of feet because you're going to fall face first into the stairs and you're leaning forward. If you are walking down the stairs, you're going to be propelled forward in the opposite direction. And you're going to be falling a lot further and probably going to be injured a little more than if you just fell a couple of feet. You know, you fall from here all the way down because you're walking down the stairs. You slip up here, you're going down. You know, if you're right here and you're walking up the set of stairs and you slip, you're just going to fall over to here maybe. Up here and walking down, it's going to be totally different. So, as I said, if you do have a situation where you have to build a set of stairs like this, and you are not going to pay attention to what your local building department says, you're going to build the set of stairs anyway. You have to. It's a tiny house, whatever, I got you. Make sure that you have a handrail. And I would definitely advise getting used to walking up while you're holding on to the handrail. That means hold on to the handrail. Firmly hold your right hand, you're walking up the stairs, your right hand is holding on to the stairway. Then you move your feet. Then you wait. Then you move your hand. Then you take 1 or 2 more steps. Then you move your hand again. Don't just hold your hand up here as you're kind of walking up here. You know, these stairways are just, they're dangerous. And I remember I had to build one time with an 8-inch step and a 9-inch riser. And this is when I noticed it. Walking up the set of stairs wasn't that bad, but walking down the set of stairs, and I didn't have a handrail. Remember, I'm building the stairs. You know, all we have are some wall studs to hang on to. And trust me, I hung on to those things with my dear life while I was walking down them. And I just couldn't believe more people didn't get injured. And I understand we can be cautious. We can be safe. And that's really the bottom line in this video. You know, if you do build a set of stairs like this, you have to understand that you're going to have to be careful using them. And every other single person who uses these set of stairs, your pets, your children, your parents, your aunts and uncles, elderly people, you know, young people, they are going to have to be extra cautious. And that is every single time you use this set of stairways. And of course, let's not even throw in the alcohol and drugs and other things that can be even more, lead to even more problems using a set of stairs like this. So here is another video in our series about the 2-story house with the open floor plan. And in this section, we are going to be going over the roof framing, ceiling joist, roof framing, and the sheathing. So we already went over the second floor framing, lower floor framing. Let's put our ceiling joist in there. Remember, I cannot provide you with lumber sizes. Not an engineer. I could give you an idea of what works, but that's something I'm not interested in doing either, because you could live in an area that would require totally different requirements. For example, a 2x10 rafter might work fine here. The ceiling joist probably going to be the same for something like this. I think I have about a 2x8. And I forget what the span is here, maybe 15 feet, something like that. I think a 2x8 works for up to 16 feet for a ceiling. But the roof rafters, 2 by 10, 2 by 12, you might be better off just getting a truss roof for something like this. But this one here is something you could probably build by yourself. A truss roof system, you'd have a difficult time getting the lumber up here without a crane. And of course we have blocking here, and the blocking is off to one side. You could center it, but sometimes you're going to have plumbing pipes or you're going to have electrical wires. I've learned that if you just move it off to one side, the electrician and sometimes the plumber can get their stuff up there a little easier. And everything looks nice there. Going to build a wall. Now in this one here we have a wall that's sitting on top of a lower wall, and this runs through the center here to support the wall and the rafters. So it's kind of one of the neat things about this particular design is this wall. I know a lot of people, a long time ago, this was a popular way to build stuff. The house I live in actually has a wall like this, and then a beam in the garage and a beam in the living room. And when I say that, it only has a wall going into the kitchen and the other bedrooms, kind of a thing. A small house, but it has a wall that is supporting the rafters or a beam with some posts. And of course, the house has to be designed to where it will actually work with something like this. And that's, of course, what I did here. So the rafters here with blocks. The rafters lap, and of course they lap to the ceiling joist. Everything works out. All the laps make everything work out accordingly. View of it there. The top of the blocks are shaped. And I have seen plenty of homes built without shaping the blocks on the top, but it really does work out a lot better for nailing the plywood sheathing. So in this one here also, I went ahead and built a different rake wall here, or end gable wall. And you can see here we have a little rafter tail at the bottom to help everything out here. And again, just kind of trying to throw out a few different design ideas or ways to build things. Something like this might need to be strapped. However, you put your piece of plywood on here and nail it, that might be sufficient to create a nice tie there. But I'm sure an engineer would want a 40-foot strap in there, strap the whole building all the way across with solid metal. Okay, probably shouldn't be bad-mouthing engineers there, but back to the video. The ceiling joist. Another view of the wall there. Now let's take the roof apart so you can get an idea of how these walls would connect here. Put the rafters back together and add the fascia board. Fascia board with the brakes and the lookouts. And of course a view of how this is connected here, and the 2x4 lookouts that are going to be supporting the fascia board. Take a look at the bridge block. Again, this is shaped. View from the bottom. And of course we have a block in here to give some backing for the siding or the stucco, whatever you're going to install on that. Another view of the small rafter here and the framing plates. And of course the break in the fascia board, usually a 45-degree angle. This can be even a 15-degree angle if you want. I've seen people do it a variety of different ways. Put our roof sheathing on. Of course, all of our roof sheathing will break and be staggered. We'll break on top of the roof rafters, half on, and be staggered. And let's go ahead and pull a sheet of plywood out so you can take a look at it. Break half on the rafter, and then this one here, of course, will break half on this rafter. And of course I have a small piece here. this might not be allowed. You're going to have to check with your engineer. Some engineers require a minimum size piece of sheathing in both directions. It might be 24 inches. And if that's the case, you're going to have to do some, you're going to be wasting some extra plywood, I should say there. Here is another video in our open floor plan 2-story home design. And in this one here, we're going to take a look at the second story wall framing. And before we do that, get started, I'm going to go ahead and remove everything underneath the wall framing so that we do not have anything in our way. So the first thing I want to point out is the top plates. Most structural engineers require a 4-foot minimum length of lumber. That'd be a top plate or a bottom plate between breaks. So this would be a break here. So if we have another break here, this cannot be smaller than 4 foot. Otherwise we got to put a strap on it. So there is a way to fix that. It's just as you're laying out the walls, you're going to want to try and get these breaks a little further away from the possible breaks in the top plates. So just keep that in mind. View from the front window here, and I have 2 blocks. The blocks in the window can be in the middle. Some people put them in the middle of the window framing. That's fine. Some of them put them in the middle of the wall. Kind of makes sense either way. If it was me, I think I'd put them in the middle or just a little bit higher than the middle because you're going to want to keep this whole area from shifting to one side. And that's actually what these blocks are going to help you do. If you don't have the blocks in there, and this board was to bow in this direction, it could pull the window frame over. If you have another stud here, this is going to provide you with a little bit of resistance. If you block all the way across, it's not moving. So mid-span blocks, my dad was a big fan of them, and I tried, this is about the minimum for me. The corners, I wouldn't even put them in the corners half the time. But my dad was a big fan of it. He believed that mid-span blocking prevented the wall framing studs from bowing and twisting, and it would have actually led to doing less wall straightening when you're doing what we used to call pickup. We used to, someone would go around, we'd have hourly workers that would go around and straighten the wall framing studs with planers or with cardboard strips and stuff like that. And he was a big fan. He believed that you weren't going to be doing as much work. So it's kind of like you're putting a little more work into something in the beginning, and then you won't have, that way you don't have to do more in the at the end when the home is built. So the blocks around the doors, here we can see where we have a 1 king stud and then a trimmer. This is a standard type of wall framing for a door that's going to open basically up against a wall. And then the block, you put a block in here, make sure that you lower it so that you are not going to have it in the way of your light switch electrical boxes. That's another problem. And I actually just took a tour of some new house framing on some track framing, and they had a couple of blocks in the way, and you're thinking like, no way, you think that they wouldn't be doing that. But again, it goes back to experience. And if you have somebody that doesn't know, which now you know, then when you do make the mistake, you can just say, crap, just like I would do if I did it again. So again, the block is lower here. And we can see the wall framing stud 16 inches on center. And this was the laundry room, stairwell. Of course, we have a window in the stairwell, give us some light into the stairwell. And this is a bathroom, closet, bedroom. Another view, and this is the master bedroom, master bath, master closet. Another view of the bedroom, or the master bathroom. And I just kind of wanted to point out that if you come to an area where you have, a 1/2 inch gap, 3/4 of an inch, something like that, you can always use a scrap piece of plywood or a 1x6, something like that. I remember framers cutting small blocks in here that were like an inch wide, and when they would go to nail them on each side, it would just split the block. So a 1 x something like that usually seems to work better in the small gaps like this. And I'm just going to kind of go a little faster through here. I noticed I was already 4 minutes into the video here, and probably said all that I need to say about the wall framing, but we'll continue to fill the provide filler information like the newscasters do when they tell you that we've got a top story here, and then it takes them 15 minutes to get to the top story. That's what I'm doing right now, just filling some stuff in there. There's closets. And a lot of times your closet header is going to be a little higher or a little lower than your door header. So sometimes the framer, the layout crew, might come in and frame it at the same height, but you better make sure that you check, you know what all the rough openings need to be for these areas, that you've either purchased your doors or your finish closet doors, stuff like that. Or just like I said, at least you know what they are. I can't tell you how many times I came to a project and it was all drywalled and finished, textured and painted, or you'd come in and put your door in, and there'd be an inch you'd have to fill in the top and put some trim on it or something to make it look right. So that is it for the video. Here is the next video in our series for building this particular house, the 2-story house with the open floor plan. In this one, we are going to go over the stairs. So let's go ahead and take that wall out so we can see it a little easier. And I kind of just want to give you an idea. I know a lot of people start with a stairway. They start with an open space. I like to show the people what it actually looks like and then take it away, so at least they kind of get an idea of what we're building here. So, and another thing I want to point out, if you are looking to build a set of stairs like this and you need a little more help, don't forget to go to our website, click on the books tab, and check out some of our stair building books. With that said, make sure that the plates run through on your bottom plates if you can. Like this, you're going to be building the wall later, but that doesn't mean that the framing plate can't run through. Nice to have this stuff running through continuous. And for those of you wondering why this plate doesn't run through, well, let's go ahead and throw the base plates in for the stairway here. And you can see that it's back about 1 3/4 inches. So here we have our base plates. They're going to need to be treated on a concrete foundation. They can be regular 2x4s, or you might not even need them. I wouldn't use these. I wouldn't use base plates on a stairway with on a wood framed floor, sheeted with plywood or OSB. Just put the stringers on top of them. And we are going to be using a plywood ledger with a line. The line is going to represent the top of the stair stringers where they connect. You'll see that here in a little bit. So we're using a 3/4 inch piece of plywood. You can always use a 2x10 or a 2x12 here. And this piece is going to represent our riser. So you're going to have to make sure that you compensate for that when you are laying out your stair stringers. Also, the plywood sheathing will need to overhang to match your stair nosing. So in this case, it's going to overhang 1 inch. And then, of course, after that, you can install your stringers. I like to install the side stringers first, and then install the ones in the middle. Now, I would like to point out one thing, and that is that the plywood sheathing here, the piece, if I was going to do something like this, I would have it go back at least 24 inches. This is too small of a piece for a stair nosing, and the reason is if you could just imagine someone stepping on this thing 25 to 50 times a day over time, since it's a small piece, it could actually loosen up because the pressure, there'd just be too much pressure on the front here. So make sure that you come back and have a piece here that's at least 24 inches. 16 inches would be the minimum, but hopefully that makes sense there. And again, we can see our stringers are nice and straight. Use a straight edge for this. Now, it's not a bad idea to put your risers in and your treads in, even your risers. But a lot of times the risers will help you straighten everything out. So I like to start by installing a riser in the middle and then line everything up. And then if everything is nice and straight, then I can go ahead and build my wall under here or install the rest of my risers. But if you build your wall, nail the blocks in, and the stringers can't move, and then you find out you have to move one of these stringers, it needs to come up a little bit or go down a little bit, that's not going to be very easy to do. So here you can see why we didn't have this plate run through, and it's back a little bit, and that's because of our riser and our nosing. We have a 1-inch nosing and a 3/4 inch riser. So this right here needs to be back at least 1 3/4 inches from the front of the wall here. We also have a 1x4 spacer in between the stringer and the wall. That's so that we could slide the drywall down instead of notching around each one of these. Definitely benefit. And if you're going to be installing a skirt board for the stairs, make sure that you use a 2x4 instead of a 1x4 if you're going to be using a 3/4 inch skirt board. Now, when I say that, I've seen some thin skirt boards before where they go in and the skirt board's about 1/4 inch. And if that's the case, you're not going to need very much here. So allow for the drywall, 1/2-inch drywall, plus the skirt board if necessary, whatever those dimensions are going to be, and then give yourself an extra 1/4 inch or 1/8 inch so that you can actually, the stuff will actually fit. And take a look at the top, and into something like this, you could toenail from 2 nails on each side, or you can go to the back and put a couple of nails in from the back of the plywood. Or you could always use a ledger. And if you do get our stair book, I recommend getting the double stair book package for the straight set of stairs, because that's going to provide you with different methods for laying out the top of the stair stringer and the bottom where it connects to either the upper floor or the lower floor. Next up on the list will be the wall here. Once the stringers are installed, you can just simply measure the height of the wall and then build it accordingly. It's difficult to do this before the stairs are in. You can get out your math calculator and figure it out, knock yourself out, but why bother? Run the plate through. When you build your stairs, that'd be the good time to build this wall. And then install your blocks and backing accordingly. And I like to let the top plates run through so that I can nail my backing to it. And again, you can do whatever you want. That's just a little secret here that I've done. And you just need one plate to run through at least. But I like to run both of them through, get some nice nailing for the backing. Our blocks, this will help keep on a longer stairway. If you have a wall and some blocks, this will add some nice structural support and stabilize the stairway a little better. I have seen long stairs move if there isn't a wall underneath them and you can't nail it to a wall. Here you're going to be able to nail the stringers to each one of the wall framing studs on each side of the stringers, and that's also going to help stabilize it. Put our risers on, and we're using 3/4 inch plywood for our risers and our treads. And here you can see the overhang 1-inch nosing. And there you can see why we had to set the stairs back a little bit to have the step line up with the edge of the wall. That's usually how the architect draws it in. We have our 1-inch overhang on the floor sheathing, and that is it for this video. Here is another video that is going to be another attempt of mine to make the process of building stairs a little easier. And I think that this right here just might make the biggest difference for those of you who are trying to build a set of stairs with a landing. Now also, don't forget to check out our book and our book packages on how to build stairs with landings And of course, the book package deal, definitely recommend getting the double book package with the laying out the stringers. Definitely going to help. It'll explain how all of the stringers are connected, what's going to be the best way to make the connection for the type of design that you are going to be working with. So let's go ahead and get started here. Take a quick tour around here. The upper stairs is located over here on our floor plan. Lower stairs over here. Here's the landing. Another view of it there. And the reason that this is going to be helpful for people who are having a difficult time, and I hate to say this, I have seen a lot of people who build stairs and they know what they're doing, got a pretty good idea, and they still would be better off if they actually snapped all of these lines or drew these lines on top of the building foundation or the floor sheathing. I cannot tell you, because you can use these lines as reference points to double check everything while you're building. So that is the key to this video. Putting a floor plan type diagram on the floor where the stairs are going to be located. And hopefully by the time you're done watching the video, it will all make sense to you. So top of the top view of the stairway, upper stringers, upper steps, and this would be the upper section over here. Now the floor plan, if you're working with an architect or a building designer, it's going to have an arrow showing which direction that the stair travel is going to be. So it might have an arrow and it'll say up on the lower floor plan. And then it'll have an arrow pointing down on the upper floor plan to give you a idea where the stairs are and how they are functioning on that particular plan. Now let's take a look at what it would look like with the floor plan drawing underneath the stairs. We can see where the front of the stair riser here lines up perfectly with the line here. Go around, we have the landing here. So all of these lines are going to line up here. Very important. Now for those of you who just aren't quite grasping the idea why in the heck this floor plan is so important, let me see if this makes sense. I'm going to go ahead and draw some boxes in here. The boxes will represent the step. This is the top of the step here. The other side is going to be the front of the riser. Now remember that the front of the riser is going to be the face of the riser. This might not represent the face of the stringer or the notch you're going to cut in the stringer. This is going to represent the front edge of the plywood or whatever materials you're going to use to create the front of your riser. So here we have the front of our riser and the top of our tread, and it needs to fit within this box in our layout. Now let's go ahead and throw another box in there. We can see here again, front of the riser, top of the tread, and this of course is the third step up. So the measurement when you are done, when the stairway is completed, top of the tread is going to be here. Front of the riser, face of the riser is going to represent this area. If you're going to use 1/2 inch plywood, then on the stringer, before you put the plywood on, you're going to be able to double check these measurements, get a level, come up and see if the stair stringer is a 1/2 inch back for a 1/2 inch riser. If you're going to use a 3/4 inch riser, the stair stringer will need to be 3/4 of an inch back so that when you nail the 3/4 inch thick riser onto the stair stringer, the front of the plywood, front of the OSB, front of the riser, face of the riser is going to line up with these lines. And of course, this is what it would look like if you had the stringers, front of the stringer lining up with these lines. You're going to nail your 3/4 inch thick plywood on top and it's going to be sticking past. So again, this isn't difficult to do. Before you nail the stringer into place permanently, set the stringer in place, attach it with some screws maybe, and then grab a level and double check everything and see what position, make sure that all of these lines line up. And you might even benefit from, if the stair stringer was cut incorrectly, you'd be able to see it right here in the lines that you have. So if you snap 10-inch lines apart on the ground and you, for some reason, laid out your stair steps at 10¼ inches, you're going to see it right here. But that isn't going to be the case, is it? Because you now have a valuable tool here to figure out exactly where to position everything correctly, right? So we're not going to end up with that problem. Now, I did move this landing back a little bit. Let's go back. I moved it back 2 inches. You could see here. This is something, again, you're going to have to adjust if you have a overhang for your stair treads. If you have an undercut for your risers or your steps, you're going to have to set this back 1 3/4 inches maybe, 2 inches to get everything to work out. So keep this in mind also for your landing. Just don't build it at 3 foot. That's one of the worst things you could do. You know, come in and, hey, you know what, my landing's got to be 3 foot. Well, it can be 3 foot as long as you have square risers, as long as you don't have any overhangs for the treads, any stair nosings. No nosings, no undercuts. Yes, then you can have it, build it at 3 foot. If not, then you're going to have to adjust and compensate for every single piece of material in your stairway to get it to turn out right. In this video, I am going to provide you with an example of what your stair stringers could look like if they were off by as little as 1/16 of an inch per riser. So let's just say that you figure out, you get the total rise of the height between the floors, the top of the first floor to the top of the second floor. You do the math and you come up with a fraction and you just kind of round it off to maybe 1/8 of an inch when you should have rounded it off to 1/16 of an inch. So hopefully this will make more sense of what actually happens to the stairway by the time you're done with the video. So what I'm going to start with are 3 different stringers. This stringer here has a 7½ inch riser height, individual riser height. Each individual riser is 7½ inches. This one is going to be 1/16 of an inch larger, 7 9/16. This one here is going to be 1/16 of an inch larger than this one, 7 5/8. So we got 3 different stringers and the same length. And I'm actually going to use the center stringer for our experiment. So this line right here lines up with the center stringer, and the top of the floor is going to be lining up with the center stringer. So here we can see where there is a difference. There are 7 risers. So we actually have 7/16 of an inch, almost a ½ inch. 8/16 of an inch is a ½ inch. So this one here that is a little taller is going to be, or has the risers that are a little taller, is going to be a little taller. And this one here, of course, is going to be a little smaller. But without you knowing what's going on, you're going to end up taking the stair stringer and nailing it to the top of a ledger or the top of a floor like this. And actually, you're going to end up with a gap at the top of this one. And you're going to end up with a gap at the bottom of this one. We can see the gap here because now we are at 2 different angles. So each one of these risers, each one of these stair stringers has a different angle. The one that is 7½ inches is 37.5. This one here, the center one, 37.1. And then this one here, 36.9. So just kind of remember those measurements. I'll remind them again later when I bring up another point when I go to longer stringers. So here we have a gap at the front, and it's tight at the back of this one. Another view of it there. Hopefully that makes sense. And of course it does with the angle, if you think about the angle. And you can also see that this, even though we haven't changed our tread measurements, these are exactly 10 inches. It's going to push this out a little bit. Now, when I'm saying this, these are computer aided drawings, and they're usually not wrong. And this is something I remember running into on job sites. If I didn't cut the stringer the right height, I mean, the risers didn't figure them out correctly. Precisely, exactly, precise measurements for the risers. They've got to be, if this comes to, like I said here, if this is 7.5 inches and, or 7 9/16 is the measurement you should be using, but you use 7.5 inches, you're going to end up with this. And you're going to be wondering, why in the heck is this thing off? I think I checked this and it was off, I want to say almost 1/2 inch. I think I checked. I think we'll have a measurement on that in a little bit. Now, of course, here we have a gap on the back of this one. So the gap on the front of the other one, the one with a 7.5 inch rise, we have a gap in the back. And of course, this is what you're going to be looking for. You set your stringers in and you have a gap in the front or the back. Grab the level, check the treads, and see if they're actually level, or if there's a problem with your calculations on your individual riser heights, and you might have made a mistake when you were laying it out. Either way, you make a mistake through the math, or you make a mistake when you figure the total rise, or you make a mistake when you are laying out the stair stringers. This could be a problem. Now I went ahead and I drew a level line, and this I believe was about 1/16 of an inch. But if we level a line across this one here is going to be level. This is what we figured the height, and everything works out correctly for the center stringer. This one here, the stair treads are going to be leaning forward. The one on the other side is going to be leaning backwards. So again, this isn't difficult to figure out. You put the level on here, you're out of whack, something's not right, double check all your measurements. Now this is where I actually learned something. I thought that these measurements would have changed. It's still about 1/16 of an inch here, sloping backwards. And of course, this is a longer stairway. The degrees of these stair stringers have not changed at all. And if you think about it, they shouldn't have. It's the same rise and the same tread height, just multiplied by this many more stringers. So treads and risers. This stringer could have 100 steps on it, and it would still be at the same angle. All three of these would be at the same angle if you were working in this particular instance. However, the measurement on the bottom is going to grow a little longer, and I really don't know why that is, but I checked the other one. And this one here that's 9/16 of an inch, on the one with only 7 risers, it was 1/4 of an inch. So this actually grew a little larger here, even though the angle hasn't changed, and we still have the same gap. And if you know the reason why that changed, or if I made a mistake with my drawings here or my computer-aided software, feel free to let us know. I am always open to any constructive criticism, as long as it's constructive. Let's not get carried away. But the gap didn't seem to change here. So realistically, on the longer stairway, we still have the same angle. We just have a little variation, a little more at the bottom than we would if it was a shorter stairway. And I can't really wrap my mind around the reason why that would be, just that it actually showed up in the drawing. So that is it for the video. If when you're laying your stair stringers out, and you're especially on a longer stairway, this isn't obviously going to be a bigger problem on a longer stairway if it's going to be the same angle. But if you want your stair treads to be as level as possible, make sure that you lay your stair stringers out to possibly within 1/32 of an inch if that's what it's going to take to create a nice level stair step for the entire stairway. Here is a video that is kind of a challenge, and hopefully it will help some of you. In the United States, we can get lumber in a variety of different sizes, but a little while ago, an individual asked if I could build a stairway entirely out of 2x4. And they said that that's the largest piece of lumber they can get in their country. And I didn't ask what country it was in. I do know that someone emailed me from Israel one time, and they were having a problem. I think a 2x8 was the largest board they could get. So if you know what country that is, feel free to share it in the comment area. But I'm going to go ahead and get started. And again, entirely out of 2x4, and you can use screws or nails to attach everything together. And to give you some measurements here, 7-inch risers, 10.5-inch wide treads. If you want to leave an 1/8 of an inch gap between everything, then the risers can be a little taller and the treads can be a little wider. And what I'm going to do is take the stairway apart and then put it back together. So it's just going to be a process. I know it's a lot of people, when they're doing how-to videos or how-to books, they just show you from a blank spot, maybe just the concrete here, and then they build it. But I think it's better to tear it apart and put it back together. And again, with these videos, it doesn't take long to do. So let's tear this thing apart. So it'll give you an idea of what you're actually going to be building when you put it together. Take the risers out, and then we can pull this down here. So you can see in this video here, I'm actually going to do this a little different. I'm building the sides up in this one, but when I put it back together, I'm going to be doing one step at a time. So you can do it this way here if you just reverse the process, or you can do it this way. So we're going to start with our bottom board here, and then put in our braces, and then we're going to put our riser in, and then our tread. So we're just going to kind of work our way up. In the other one, if you remember, we didn't put our risers and treads on. We built the side of the stairway first, but this way right here might be a little easier. Risers, and another view of it there. Go ahead and put a couple of more support boards in. And these braces here are critical. They're going to hold this together, and you might actually need to put a couple of them over here. If you think it's going to be weak, it wouldn't be a bad idea to put another brace in. And that can always be done after the stairway is built. But, while you're building it and you get to a certain point, and you're not going to be able to get to it from the back. Even like this point here would be good. You could come in here and just put a brace in here, or have it come up a little bit. Let's move it back there. You could have it come from here down. This would kind of be in the middle. So it would start up here and then go down to here, and that would stiffen this up. But as you nail everything together, you're going to see that these boards and these boards here are going to strengthen everything up. You're going to have a nice connection here. You're going to be nailing or screwing into the braces, or through the braces here into the other sideboards here. I'm going to show you more on the nailing here at the end of the video, give you an idea. And again, if you have any questions, feel free to leave them in the comment area. I know that when I'm building this stuff and on the computer, I can see, okay, this is a problem, like I'm doing here. I didn't put the riser in here because I need to be able to get this top support brace in. I need to be able to attach the brace to these sideboards here. So you can see here, if I put this board on, I could still get to it, but I'm not going to be able to get to it if I put the top treads on. So you could always put the riser on here, as long as you're going to be able to have enough room to access some of these other spots, and then simply cap it off, and you are done. But don't turn the video off yet. Let's take a look at how we would nail or attach these. You can use nails or screws, whatever you feel is going to work best, and simply nail. And I don't think one nail is going to be enough for a 2x4. You're probably going to need 2 nails. Center them on the where you're going to be nailing into these boards below it, and maybe about 1 inch or 3/4 from the edge. And if it splits, pull the nail out and move it over a little bit. And then, of course, you can nail down the front of this to connect these 2 boards together. And the risers, again, 2 nails. And then the brace, you can use 1 nail per board, or you can use 2 nails per board, or use 2 nails, 1 nail, 2 nails, whatever you feel, or screws. And, of course, you can always nail the back of the riser into this tread to create a stronger step. Without these nails here, you might not have a very strong step. And if you're worried about this one here, this one's going to be sitting on top of here, and then you're going to be screwing this. You're going to be making this one here a little stronger, but this one here in the middle might not be stronger. You might need to put a board on the bottom of this and screw it from the top, or screw it from the bottom, or even a couple of support braces in there to get a little stronger connection. And again, if you have any questions about that, feel free to leave them in the comment area. That is it for the video. And something like this seems like it would work. If you do build something like this and it's not working, it doesn't work out, let us know what you're having a problem with. A lot of times I'll draw something on the computer, and this is something I've never built before physically. I just kind of trying to help somebody out in another country who can't get larger pieces of wood. You might have to work with something like this. And in order to work with something like this, you might have to modify it, in a certain way. And again, I have 2 kind of braces here, and this is a 3-foot wide stairway. And like I said, if this right here is going to be a little loose, you could always put another one of these support side stringers, let's say, in the middle. And you would use 3 of these, and that would take the place of 3 stringers. And then, of course, that would really make it a lot stronger. In this video, I will provide you with a reason why air bubbles might be coming out of your toilet. And I'm going to break this video into 2 sections. First section will be the 2-dimensional drawing here that you are looking at. And this would be simply if I took a line, or let's just say that I sliced a section of the toilet in half, and you were looking at this from the side, then this is what you're going to be looking at. But I'm also going to have some pictures at the end of the video. Now, for those of you looking for the short version, why air bubbles are coming out of your toilet, it's just because you have a clogged pipe. And of course, that clog can be partial. A partial clog is something that's going to allow some of the water and some of the debris to go through the pipes, while another clog might be completely plugging everything. If you do have a clog that is plugging everything and not allowing any water to go through, then there's a very good chance the water is going to fill up into the pipes and then flow over the toilet. But I have seen it before where you have a clog. It's a wad of toilet paper, some poop, and it kind of wads up. And then when the water builds up in the pipes, it creates enough pressure to unblock the clog, or partially unblock it, allowing some of the water to flow out. And if that's the case, some of you might be experiencing where you have air bubbles coming out of the toilet bowl. Or even the toilet bowl might fill up a little bit, and then all of a sudden it just gives way and flushes by itself and sucks a lot of the water out of the toilet. And if that's the case, there's a very good chance that this is what's happening. Some of the water is pushing the weight of the water, the volume of the water, puts enough pressure on the clog to loosen it up or unblock it completely, and then all the water drains out of the pipe. Now, here's how the air enters into the situation. So when you have a clog and you're getting water, whether the water is coming from the toilet or other parts of the plumbing, bathtubs, showers, or sinks, you can actually have a pipe fill up. And the minute that the pipe fills up to where the air is going to be trapped in this area. So if you can just imagine, as the water is filling up in the pipe, it's going to reach a point where it's going to block off this pipe here and trap all of the air. So as the water rises in this section here, it's going to force air out of the easiest path. And that is where the air bubbles are going to come from in your toilet. Now, once the water level reaches the top of the floor, you can actually have water leaking out of the base of your toilet. This isn't uncommon. You have a wax ring that is sealing the toilet to the plumbing pipe. And if this wax ring has any gaps in it, then water, of course, is going to leak out of this. So as you're seeing the air bubbles come out, you're going to see water coming out of the base of your toilet. Again, this should give you an idea how high the water level is. It's going to be a little higher than the floor probably at this point. Now, the moment that the air bubbles stop coming out and the water level starts to rise, then your plumbing pipes are going to look something like this. And I don't think I mentioned that this is the drain pipe here, but from here up is the vent pipe. And this allows air to come into the plumbing system. And this air prevents the traps in the toilet and your sinks and your bathtubs and showers to remain filled with water. And I'm not going to go into a lot of detail on this in this video here. This is just about the air bubbles. Don't want to get carried away, but if I do have a link, I will put it here for those of you interested. So the water is going to rise and stay level. And or around level, I should say, because I've actually seen this go up and down. One section will go up and this will go down, kind of a thing, and vice versa. But for the most part, you're going to be looking at something like this. Once the water level reaches this point here, it wouldn't be uncommon to find water in your shower and in your bathtub, because the water is going to be coming out of those pipes also. Now, in the second section, we'll take a look at a few pictures. Now, of course, the air bubbles coming out of your toilet bowl are going to be coming out of the water in the toilet bowl. And, of course, here is a toilet that is sealed. So a very good chance you're not going to have water coming out of the bottom of this area if it is sealed completely. Now, you can solve a problem, one of the problems. If you have your toilet bowl filling up and water leaking out, you can always seal this area, but I really don't recommend doing that until you have fixed your problem in the first place. Otherwise, you could have water leaking, you might not see it on the floor here, but it might be leaking onto the floor framing below if you have a wood frame floor, or into the concrete, or leaking into little cracks and creating problems later on down the road. Now let's take a look at the waste pipes. Now this is a plumbing system in a home built with a wood framed floor. So the plumbing pipes are going to kind of look similar to this if you have a concrete foundation. This is actually the toilet drain pipe. And then this is a vent pipe here for the toilet. So if there was a clog over here, let's just say there's a partial clog over here or a complete clog, and the water starts backing up, it's going to fill up this pipe, or I should say it can fill up this pipe. Now, once this pipe becomes filled with water and starts to rise in this area, so just imagine this whole plumbing system is filled with water, all of these pipes, and it starts to rise. That's when it's going to trap the air in this pipe. And once the air is trapped in this pipe and has no other place to go, that's when it is going to come out of the toilet bowl. So, it's not uncommon you're sitting there You're looking at the toilet and air bubbles are coming out right after someone has taken a shower or a bath, let all the water out of a bathtub. And of course, why is that? Because these plumbing pipes are filling up with water faster. So again, I hope that makes sense. This isn't a real complicated problem, but it is going to be caused most of the time from just a partial clog. You just call a plumber or go down to a rental yard and clean these pipes out, and that will probably solve your problem. This is going to be the first video in a series of videos I'm planning on making for people that are just starting out in the home building business or do-it-yourselfers who are looking for the basics for home building. And I'm kind of, there's a lot of things that I make videos about, and they're a little more advanced, and sometimes they don't have enough information in them. Like even nailing two pieces of wood together. I don't have any videos on that. I'm planning on making some videos and putting them in this playlist, and that's kind of what it's going to be like. So like I said, there'll be a link at the end of the video, and this video here is actually going to be about the lumber spacing for wall framing studs, roof rafters, ceiling joists, and other components in your home, and why they're spaced at those increments, kind of a thing. So let's go ahead and get started. In our first example, we have 12-inch on-center or 1 foot on-center wall framing stud spacing. And here we have 9 studs, and this is going to kind of play an important role in what we're doing here. And this isn't going to be a very common measurement. 16 inches on center is the most common, but I kind of wanted to go over here and give you an idea of what the on center measurements are. And the on center measurements is going to be basically from the center of the wall stud to the center of the next one. And that same measurement can be taken from the far left to the far left or the far right to the far right. Not from the far left to the far right. But as long as you keep the measurements on the left side, all of your measurements and your spacing, and nail all of your framing studs accordingly, then you are going to end up with the on-center measurement. Center of the wall framing stud, center of the next wall framing stud. So here's the last example for that. On the right side to the right side. A lot of people, I get a lot of questions. People are trying to figure out what the on-center measurements mean. What exactly does it mean? So hopefully this makes sense. Here we have a wall with 16-inch on-center wall framing studs. Center of the wall framing stud to the next one, and the next one, and the next one. And of course, in an 8-foot section here for 16-inch on-center increments, we're going to end up with 7 wall framing studs. So we're going to be working our way down to using less wall framing studs. 12 inches on center was 9 framing studs. 16 inches on center is going to take 7 wall framing studs. And of course, 19.2. This is another measurement that's actually on your tape measure. Check it out. If you have a 25 or 30 foot tape measure, go to 19.2 and you're going to see a little diamond or a little mark. And then if you go to, what would that be, 38.4, you're going to see another one. And with that said, if you look at your tape measure at 16-inch increments, 16, 32, 48, you're going to see, it might be in the color red. You might have a different color for all of those because that, of course, is the most popular. And I think all of the 2-foot measurements might even be a different color also, but might not. Don't quote me on that one there. So here we have 19.2 in an 8-foot wall. We are going to use 6 framing studs. 2 foot on center is going to provide us with 5 studs and 4 spaces. 32 inches on center, and this isn't going to be very common. This isn't one I see very often. You might see something like this with 4x4, 4x6 post, maybe in an area where they're going to put glass or something like that. But just to have this, this is just a little too far. Same thing with 4 foot on center. 4 foot on center, again, you're going to see this maybe when you're using posts and beams, where each one of these is going to be a 4x4 post. And for those of you wondering why in the heck we have selected these specific numbers, it is because most of this works out with 8-foot increments for plywood and drywall and some other building materials. So this is why we came up with these specific measurements. 4 foot on center, 2 foot spacing. If we grab a piece of plywood or a piece of drywall that's 8 foot long, we're going to be able to nail it to the center of this particular framing stud and the center of this one here. Same with these other measurements here. So 4 wall framing studs, 5 wall framing studs, this still works. Now I do got to point out that 32 inches on center and the 19.2 inches on center will work for 8 foot on center, but it will not work for 4 foot on center, where of course 4 foot will, and then 2 foot, 16 inches, and 12 inches will. So I hope this makes sense for reasons why we're laying them out at 16 inches on center instead of 18 inches on center, or 15 inches on center. So these measurements are made to divide into 8 feet for layout purposes. Now, if we flip the plywood around, instead of having it horizontal, it will be vertical. You can see here where the plywood, and these are wall framing studs at 92¼ inches, by the way, for 8 foot. That's something else that you need to be aware of. If you use 8 foot studs for your wall framing studs, you are going to have a problem. Your drywall and your shear panel, all of your plywood, isn't going to work out. So remember, specific measurements for your wall framing studs according to the building plans. Take a back view look at it here. So remember, the plywood is breaking on this particular stud, and let's take a look at how that would work out. So if you lay everything out 16 inches on center, center to center, the 4 foot and 8 foot measurements should work out. So hopefully by now you have a basic understanding of the increments used in construction and why they are used. And a lot of it has to do with the 8 foot units of material, plywood and drywall, that are used to cover the outside of the building and the inside of the building.